Very first off, we want to factor this. We have a common factor we can cancel. But when we cancel something from our denominator, we got to remember to keep the domain restriction that x can't be equal to 3. So our x-intercept will be 3, 0. Set the numerator to 0. Our y-intercept will be 0, negative 3. You set x equal to 0. Our vertical asymptote will be x equals negative 1. That's what makes the denominator 0. Horizontal asymptote, let's take the ratio of our leading terms. We have x over x, which is just equal to 1. So our horizontal asymptote is 1. And we have a hole at x equals 3. That's not in our domain. And let's find the y value corresponding to that. So when we plug 3 in for x, we get 3 minus 3 for 3 plus 1. Well, that's just 0. So actually that's our x-intercept. So we have no x-intercept, but we now know where our hole is. Okay, let's draw a rough draft, and then we'll find additional points to make it even better. So now we pick a starting point. How about the y-intercept? Let's ask ourselves if we go down or up. If we go up, we're going to have to cross the x-axis to get there, but there's no x-intercept there. So we have to go down. Okay, our next spot would be up to here, to our hole. Now let's see if we're going to touch or cross. X minus 3 has multiplicity 1, so we're going to cross and go along our horizontal asymptote. Now on the other side of our vertical asymptote, we need to decide if we're going down or up. Let's look at the multiplicity of the factor that it comes from. It's 1, so it's odd. So that means we switch signs as we cross, so we're going to switch from going to negative infinity to going to positive infinity. And there's no more x-intercepts that we could cross and maybe have a bump and go up, so we will just do this. Let's find some additional points to make it more accurate. I would say the only one we really need to do would be something on this side. So let's do a negative 2. So let's plot the negative 2, 5, and fill in our graph. There it is.